All right, so today we've got a stack of specs from HD Supply, and we're doing a deep dive into something that, on the surface, looks deceptively simple. We're talking about a cable.
Yeah, the Kramer CLS-AOCU32. And, it sounds pretty mundane
Right.
until you're the one actually trying to set up a professional workstation and things just don't reach.
That's the thing. We all just ignore cables until they're too short or they break.
Hmm.
But this Kramer unit, it seems to be solving a real physics problem.
Yeah.
It's a USB-C cable, but it's 25 feet long.
Right. And that length, that's the whole headline here. I mean, if you look at a standard copper USB-C cable, you're lucky to get, what, 3 feet? Maybe 6?
And after that, the signal just dies. Why is that drop-off so severe?
It's a principle called attenuation. As electricity travels down a copper wire, the wire itself has resistance and it just eats away at the signal strength.
So it turns into noise.
Exactly. If you try to push something like 4K video down a long copper cable, the other end just gets static.
Okay, so how is Kramer getting to 25 feet with this one? The specs call it an active AOC.
And that stands for active optical cable. This is where it gets really cool. Inside that cable jacket, it's not primarily copper carrying the data.
It's fiber.
It's optical fiber. It literally converts the electrical data signal into pulses of light, shoots it down the glass fiber, and then converts it back on the other end.
And light doesn't have that same resistance problem.
Not at all. You don't lose signal quality over that kind of distance.
But wait a second, the specs also say it delivers 100 watts of power. You can't send electricity down a glass fiber to charge a laptop.
Exactly, you can't. And that's why they call it a hybrid cable. If you were to, cut this thing open.
Which we don't recommend.
No, you'd see the tiny glass fibers for the data and video, but running right alongside them are actual copper wires.
Just for power.
Specifically to carry that 100 watts of power, and also some of the legacy USB 2.0 signals.
So it's basically two different cables wrapped in one jacket to get the best of both.
Precisely.
So let's dig into what that hybrid build actually lets you do. We see USB 3.2 Gen 2 listed here.
Yeah, that's the data standard. It means you're getting 10 gigabits per second for file transfers. But for most people buying this, the video capability is the real showstopper.
Which is 4K resolution at 60 hertz.
Yes, but there's a little note in the specs here that's really important. It says 4.4.4 color sampling.
Okay, that sounds super technical. I usually just hear that and think better picture, but does that actually matter if I'm just looking at a spreadsheet?
It actually matters more for a spreadsheet than for a movie. A lot of long cables cheat to save bandwidth. They compress the color data.
Subsampling, right?
Exactly. In a movie, you'd never notice. But on a computer monitor, that compression makes fine text look blurry or have these weird color fringes. 4.4.4 means no compression at all. The text is perfectly crisp at 25 feet.
And while it's pushing that perfect video, it's also sending the 100 watts we mentioned.
Yep, 5 amps at 20 volts.
Ugh.
So you can have a laptop on a conference table with the single cable running across the room to a big screen on the wall, and it's handling the uncompressed video, high-speed data, and charging the laptop all at once.
You don't even need a separate dock then.
It basically puts the dock inside the cable.
Okay, what about the physical connector? Kramer lists something called K-lock. Is this some proprietary thing I have to worry about?
No, and that's the smart part. It fits any standard USB-C port. The difference is internal. Normal USB-C just relies on friction to stay plugged in.
Which isn't very much.
No, it's not.
Yeah.
K-lock is a mechanical design inside that connector that just increases the retention force. It actively grips the port. So if someone trips on the cable,
It doesn't just pop right out.
it takes a lot more force to dislodge it. Think about a permanent install, like a ceiling projector or a medical cart. An accidental disconnect there is a major problem.
I also noticed the jacket material is listed as low-smoke halogen-free.
That's a safety compliance standard. It just means if there's a fire, the cable won't release a bunch of toxic smoke. It shows this is really built for commercial infrastructure, for running through walls and ceilings, not just for your desk.
It really feels like we're moving past the era where a cable is just a dumb, passive wire.
We absolutely are. We have to start thinking of them as active electronic devices now.
It completely changes the perspective on what connectivity really means and what it costs.
It really does. And it leaves us with this sort of lingering question, doesn't it?
Yes.
If we have to resort to lasers and fiber optics just to move data and video across a medium-sized room, have we finally truly hit the absolute physical wall of what copper can do for us?
That is definitely something to think about. Thanks for listening to this deep dive.